is executed, so we can implement conditional code execution, and how often some code is executed. So we'll be able to execute some code repeatedly based on some condition or certain circumstances which we as a developer can set. Now, we are going to learn all about that in this course section, and as always, we are going to learn about that in theory, but also with concrete examples. Allow us as a developer to control under which conditions
Mobile games are going big. Clash Royale is now available on PC with Google Play Games.
I'm back in our main project here, so outside of this exercise 2 file, back to this main index.html file, which I again opened with live server so that I see this demo from before again. Now we want to explore control structures. And that of course brings up one very important question. What exactly are control structures? In JavaScript, and basically in all programming languages, we have two main kinds of control structures. Because when we talk about control structures, we mean special JavaScript language features, a special syntax that allow us, as a developer, to control under which conditions certain code is executed, or how often some code is executed. And when it comes to controlling whether code is executed or not, so to the left part here, then we are talking about if. I'm back in our main project here, so outside of this exercise 2 file, back to this main index.html file, which I again opened with live server so that I see this demo from before again. Now we want to explore control structures. And that of course brings up one very important question. What exactly are control structures? In JavaScript, and basically in all programming languages, we have two main kinds of control structures. Because when we talk about control structures, we mean special JavaScript language features, a special syntax that allow us, as a developer, to control under which conditions certain code is executed, or how often some code is executed. And when it comes to or how I'm back in our main project here, so outside of this exercise 2 file, back to this main index.html file, which I again opened with live server so that I see this demo from before again. Now we want to explore control structures. And that of course brings up one very important question. What exactly are control structures? In JavaScript, and basically in all programming languages, we have two main kinds of control structures. Because when we talk about control structures, we mean special JavaScript language features, special syntax that allow us as a developer to control under which conditions certain code is executed, control under which conditions.
Special JavaScript language features that allow for the control in which under which conditions code is executed. Special JavaScript syntax features that allow you to control under which condition code is executed. Special JavaScript language features that allow for the control in which special JavaScript language features that allow for the control in which special JavaScript syntax / features that allows you to control under which conditions code is executed. Special JavaScript features that allow for the control in which code is executed.
Certain code is executed, or how often some
code is executed.
some code is executed. And when it comes to controlling whether code is executed or not, so to the left part here, then we are talking about if statements as a language feature that allows us to do that. On the right side here, we are talking about loops. that allow us to execute some code multiple times until some condition is met or anything like that. And of course, we're going to dive into both, but we are going to start with if statements, since that is also what will help us implement that feature that we change the color of this span here and the background color of this input if we go below 10 characters of remaining characters. Now, in order to get started with if statements, though, I'll add a new file. Conditional code.js. And I'll add this conditional code.js file instead of the demo.js. File here in my index.html file, so that this conditional code.js file will get executed. And here I want to show you the general syntax for writing conditional code. Let's say we have some code where I console log hello, so that we would see this in the developer console. But I only want to execute this if my name is Max. So here I'll add a variable or a constant named my name, and I'll store a value of Max in there. Now, of course, for this example, the value will always be Max, because I'm not extracting that from some user input or anything like that. Instead, I hard-coded this here into my code. But let's again assume that this is dynamic, that this is a value we are fetching from some user input, and in case it's Max, I want to console log hello, otherwise I don't. To make that work, we need to write a so-called if statement. And we do that by using the if keyword, which is a reserved keyword in JavaScript, and then we add brackets, parentheses, and we'll put something between those brackets soon, and then we add curly braces, opening and closing. So it looks a bit like a function, but of course we don't use the function keyword, and we also don't give this if statement a name. Instead, it's really just if, then this pair of parentheses. I do add a blank here. It's technically not required, but recommended for readability reasons. And then another blank, which is not required, but makes it more readable, and then curly braces. And then I'll hit enter to readability. I do add a blank here. It's technically not required, but recommended for readability reasons. And then another blank, which is not required, but makes it more readable, and then curly braces. And then I'll hit enter to start a new line. Just as with functions, this new line is also not required, but adding a new line and indenting our code here by hitting that tab key on our keyboard again makes it more readable, and therefore we typically use this way of writing our control structure code as well. And then I'll cut this console log statement and insert it here, indented between those curly braces. Now that's an if statement, but an if statement that won't work, as we can also tell by these red squiggly lines here, which indicate that we have an error. And the error is that an expression is expected, which basically means we need to put some code between those brackets. But which code? If statements need Boolean values between those brackets. And we also call those values just Booleans. And that's another value type. Besides strings and numbers and objects and arrays, Boolean values are a special value type that have exactly two possible values, true or false. So it's like yes or no, just that it's called true and false. And these two values are our Boolean values we can work with in JavaScript. So whereas a number can be any number and a string can hold any text, a Boolean value can only hold either true or false. And these are useful, these values, if we have a yes or no question. And when do we have such a question? Exactly, if we have an if statement. Because we want to execute some code, the code inside of these curly braces in this if statement, if a certain condition is met. So if this here says yes, then we want to execute the code. If it says no, so false in the Boolean world, then we don't want to execute this. Now we could directly add true here as a value, and very important, here we don't have quotes because we don't want a string like this. Instead, true and false are values which are built in as keywords like this. And if I would set this to true, then this would execute. If I now save that code and I open my console here, we see hello.
Why?
And on the other hand, if I set this to false and I save this, then we don't see anything. Because then that code in the if statement does not execute, because that does not answer the question whether the code should be executed. So if that code should be executed with true, instead it answers it with false, which means no. So if false, then do nothing. If true, then execute this code. This is how you can read this. Now, Boolean values are super important in programming because we need them for control structures like this, because we need them for if statements. And as you will see, in most programs that you write, you will have some parts of your code that are actually conditional, that need if statements so that you can control which code should run and if it should run at all. But you will typically not hard code true or false into your if statement as we are currently doing it. Why not? Well, because then the entire if statement is redundant. This will always be true and this will always be false, so that's not too useful. I only did that to introduce Boolean values. Instead, you will typically derive Boolean values with help of so-called comparison operators, and also sometimes with logical operators. And I will, of course, explain both types of operators. Up to this point, we did learn about those moth operators and the concatenation operator, this plus, which we can use on strings. Comparison and logical operators are additional sets of operators which we can use in JavaScript. But whereas mathematical operators yield us numbers and the concatenation operator returns a string, comparison and logical operators will actually give us Boolean values. And let's start with comparison operators. Here we got these operators which we can use to compare values with each other. The first set of operators here is the equality operator. And there we have two kinds of equality operators with 2 and 3 equal signs. And I'll show you the difference in a second, but basically we use these operators if we want to compare two values for equality. So for example, if we would want to check whether 2 is equal to 2 or 2 as a string is equal to 2, and you see that would actually give us false if we use that triple equal sign operator. But again, I will explain it in greater detail soon. And you see a couple of other examples down there as well. This equality operator can be used to compare numbers with numbers, strings with strings, numbers with strings, and a couple of other values as well. It also has a couple of gotchas, but again, we will see that throughout the course. And in general, the deeper you dive into JavaScript, the more you will learn about those gotchas. But it generally works quite straightforward. You can use it to compare values for equality. And of course, in the examples here, I have hard-coded values only. In reality, you would typically compare values that are entered by a user in some input field from which you got the value, or which you fetched from some website, or anything like that. Because otherwise, of course, if you hard-code values, you already know the answer in advance as a developer. These are really just examples here. Now, the next set of comparison operators are these greater than, lesser than, greater or equal, and lesser or equal operators, which allow you to do these exact operations, where you can check whether 5 is greater than 3, and so on. It is worth pointing out that you can also use these operators on strings, and there A would, for example, be smaller than B because it comes earlier in the alphabet. So that's also worth mentioning here. Now, the last set of comparison operators, which you see here, are negation operators, or operators that yield the inverse of what you're checking. So you can check if something is not true. And you see a couple of examples here. Please note that in the first line, I'm also using brackets, so that 4 smaller 4 is evaluated first. And that would normally yield false, because 4 is not smaller than 4. But with the negation operator, the exclamation mark here, I then get the inverse of that, and the inverse of false is true, and that's how we derive that value. And that's also sometimes exactly what you need. Now, sometimes you don't just have one check that you want to perform, but multiple checks. And then it's the overall result of combining all those checks, and therefore combining all those Boolean values which result from these checks, and that's exactly where logical operators can help you. Here we got two kinds of logical operators. We got the AND and the OR operator. And with AND, we get true if both compared values are true. And here are some examples for how that would behave. And with the OR operator, we get true if one of the two values is true. So here it's enough if one of them is true, and you see some examples here. Basically the same examples as on the left, just with OR instead of AND. And now that's of course just an overview and a summary. We are now going to explore these operators and play around with them in code, and then see how we can use them in conjunction with if statements to do more useful things there. Now, to play around with those operators, I'm back here in the console, this JavaScript console in the DevTools, since we can quickly enter code like this here and instantly see the result, which is more convenient than typing it here and then executing the code and then seeing it here. So that's why we'll continue here. And let's play around with those various operators I showed you. And for example, you see we can compare numbers with each other for equality, and I did mention that we have two kinds of equality operators there, with 2 and with 3 equal signs. And what's the difference? The difference is that if you use the one with 2 equal signs, you compare the values only. And as a consequence, if you would compare the number 5 with the string 5 with the 2 equal sign operator, you would get true. With the triple equal sign operator, you instead also check for type equality. So for this comparison, you get false, because whilst the value is the same, 5, the value type is not the same. One of them is a number and one of them is a string. And these are different value types, as you learn. And therefore, it is generally considered a best practice to always use the triple equal sign operator, because typically you should compare equal types. Of course, if you know that you need to compare a string to a number and you want to check for a value only, it is fine to use the double equal sign operator as well.
Ah, okay.
Now, we also learned about the negation operator, and there we could check if 5 is not equal to 5, which of course is false, because they are equal. And for example, checking if 4 is not equal to 5, therefore would yield true. And here, we would also actually get true if I check for 5 not being equal to 5, if the second 5 is a string and the first one is a number. So that's how we could use this negation operator. It also exists on one equal sign only though, and then here I would get false, because now again we only have a look at the value. Now besides equality or not equality, we can also check for values being greater or smaller, and for example we can check if 3 is greater than 1, and if 4 is greater than 6, which of course is not. We can check for A being greater than B, which it is not, because B comes after A in the alphabet. And we can check if CB is greater than AB, which it is, because if you have multiple characters in a string, the characters are compared character by character. So first C and A is compared, and if we have a winner there, then we're done. And only if they would be equal, it would move on to the second character and compare those with each other. But here C is greater than A, and that's why we overall get true for this comparison. And we can also check for equality, so greater or equal, and that would also behave just as you would probably expect it. Now, it is worth mentioning that you can't combine the negation operator with those kinds of comparisons just like this. So you can't do that. You see, you get an error. Instead, here, you would first execute this comparison, wrap it in brackets, and then add your negation operator in front of it, because you can always use this negation operator to convert a true value to false or a false value to true. And that's essentially what we're doing here then. We are first deriving a true or false value, and then we're getting the inverse of it. Now that were our comparison operators. We also got the logical operators. And here we got and or. And here the idea is simply that sometimes we have multiple combined conditions. For example, we could be checking if 5 is equal to 5 and if 3 is equal to 3. And that would return true because both individual expressions here yield true. If we would have at least one expression that yields false, the overall expression would yield false with that and operator. With the or operator, on the other hand, it is enough if at least one of the two expressions yields true. So there, if we had basically the same line of code, but with the or operator, we would get true now because at least one of the two yields true. Of course, if both yield false, for example, if I change this 5 to a 6, then we would also get back false as an overall result here. Now, it's also worth mentioning that you can combine as many comparisons as you want. For example, we could be saying that we want to check if 2 is equal to 2, or if 2 is equal to 3, and we want to check if 5 is equal to 6. And what you see is that if I would execute this, it would work, and I would get true as an overall result, because by default, this will be evaluated or read like this. JavaScript will first evaluate this part with the AND operator, since this has higher priority in JavaScript. And therefore, the result of this comparison will be false, because both conditions here actually yield false. But even if just one of them would yield false, this would still overall yield false, because that's how the AND operator works. But then you see that the overall result is true, and that tells us that JavaScript then takes the result of this second comparison here with the AND operator, and of course combines this with the first comparison here with the OR operator. And you learned that therefore this overall will yield true if at least one of the two operations that are compared with that OR operator yield true. And that's the case because this first operation yields true. Now, just like in regular math, you can override this built-in priority by adding parentheses. If you want to say that you don't want this second part here to be evaluated first, but instead you first want to check this OR operation and then combine that with the result of this last comparison, you can do this by simply adding parentheses here. Now you see, we overall get false, because now JavaScript will first of all make this evaluation here, and that of course yields true, because, well, both sides of OR return true, but it would even be enough if just one of them would yield true. But then the overall result of this first comparison, of this first evaluation here, is combined with that last comparison with the AND operator, and therefore we overall get false because this yields false. 5 is not equal to 6, and you learned that for AND, both sides need to yield true, and that's not the case here, hence we get false. So you can combine as many comparisons as you want, and you now also learned about the priority of the different operators. And that's it for this introduction to Booleans and these comparison and logical operators. Of course, playing around with numbers in the console like this is not what we would do in real apps, but it is useful to understand these operators. I'm just giving you this overview right now so that we can then use all these features later throughout the course, but of course there you will then also see them in more realistic scenarios. For example, back here in this example code I started with earlier. Now that we learned about comparison operators and logical operators, here we could say that we want to print this if the name is max. So here, instead of hard coding true, we could say we want to go in there and execute this code in the if statement if my name is equal to max. Using the triple equality operator here to also check for type. And if I save that, I get hello, because of course that is equal. Now it's still kind of the same as hard coding true right in here, because my name is hard coded, but again, let's just assume that this is coming from some dynamic input. But now that we got this and we know basically how that works, we can go back to our demo.js file, and in there, we could now alter this function a little bit to actually add this warning clause here, which is defined in the CSS file, to our span and to our input. So the two elements we store here, if the remaining characters here are smaller than 10. Definitely try this out on your own. We'll do it together in the next lecture. So, were you successful? Let's do this together. We want to make sure that we add this warning clause here to the input and to the remaining characters span if we have less than 10 remaining characters. And with our newly gained knowledge,
not get caught selling snacks at school. So the main issue with selling snacks at school is you can get caught, suspended, and they can take your stuff away and shut your business down. See, the schools don't want you making money. They don't want you being a young entrepreneur. So there's ways around it that I use so I can still sell at school. Before I even sell, I sit down on my spot and I look around. Keep an eye out where your securities or teachers or just the principals at. If you see or hear someone coming, just put your stuff away, hide it. Act like nothing's going on. And don't make it obvious. Tell the people that you're selling to hold their money till you get the stuff out and then you make the exchange at the same time. And I do not recommend selling in class. It's the easiest way to get caught. When I be selling, I be trying to go in the buildings like in the corner where nobody can see me. But be careful. I make a video on how to not get robbed. This is how T-Mobile built to not get caught. Do you even want to hang out? Do you even want to hang out? Oh, let's consider it. Like I said, whatever. Like I said, whatever? This guy. Do you even want to hang out? Do you even want to hang out? Stay. Stay. Okay, come find me. We attempted to cook an entire 10-pound pork loin on the job site using a wheelbarrow to hold the charcoal and a giant rotisserie spit attached to the auger on the skid steer. Here's how it turned out. We slathered the pork loin in gravy upon mustard and sprinkled on slathered mama seasoning. I made this spit using some scrap pieces of pipe and couplings and bolts right onto the auger just like a bit. Once the pork loin was roasting, I made a glaze out of some ketchup, apple cider vinegar, Worcestershire sauce, a little bit of brown sugar, salt, pepper, and finally my homemade hot pepper powder. This stuff is deadly. I dumped the glaze on the pork loin and used a mini roller to smooth it out. Don't worry, the roller was brand new. There's no way to describe how amazing this smelled as it was cooking. I would definitely recommend using a meat thermometer if you're going to cook one of these. It takes all the guesswork out. We let it get up to 160 degrees in the middle, and it turned out absolutely perfect. This pork, along with the buttered baked potato. This was awesome. Let us know in the comments. What should we cook next on? It's your. Do you remember the Nerf time? I was just. We attempted to cook an entire 10-pound pork loin on the job site using a wheelbarrow to hold the charcoal. It's your. Do you remember the Nerf type? I was just walking my fully trained dog when this happened. This customer called me out to an incomplete job. This is what happened. Last summer, I received a call to come finish striping this parking lot because the customer was unsatisfied with the work that another contractor had provided. As I was completing the job, I noticed that the concrete had also been halfway pressure washed, and I reached out to the customer to see if they would like to get it completed. After reaching out to the customer, they told me that they didn't have the funds to complete the pressure washing, but if they ever wanted it completed in the future, then they would give me a call. After I finished striping the parking lot, the customer thanked me for completing it and told me that they were very happy with the results. Fast forward to earlier this morning, and I received a call from this customer. After answering the phone, the customer told me that they had received several compliments on their freshly painted parking lot. I told the customer that I was glad that they were happy with the results, and I asked them how I could help them. The customer told me that with springtime approaching, they are going to have several events at this building, and they wanted to know if I would be interested in pressure washing the entire. What's up? Go get your boys. Go get them. What's up? Fuck you. You were breaking cars? Are you a fair bub? What's up? Oh, I got a right, you pussy. What's up? Go get your boys. Go get them. What's up? Fuck you. You were breaking cars? Are you a fair bub? What's up? Oh, I got a right, you pussy. What's up? Go get your boys. Go get them. I'm the only one on the planet dropping molten glass into WD-40 to see if it will make a Prince Rupert's drop. The hot glass causes cool swirls, and it's by far the best smelling one yet. This drop is a prime specimen of Rupert's drop, with a smooth body and tail. It's also been able to withstand blows from the hammer, denting the metal underneath. It even explodes when the tail is broken. I'm the only one on the planet dropping molten glass into WD-40 to see if it will make a Prince Rupert's drop. The hot glass causes cool swirls, and it's by far the best smelling one yet. This drop is a prime specimen of Rupert's drop kind, with a smooth body and tail. It's also been able to withstand melting glass into beer and wine to make a Rupert's drop. Fun fact, beer is one of the oldest beverages dating back to 5000 BC. There's a common myth that drinking red wine can have health benefits, but unfortunately, many studies show that drinking any amount of alcohol on a regular basis can be very detrimental to your health and cause cancer. Fortunately, Rupert's drops don't cause cancer, so let's make one in wine. Beer, unlike wine, has carbonation from the fruit. In the holidays, sanding down the tail of a glass drop that explodes when it's broken sounds like a great idea. Using 220 grit sandpaper, the drop was definitely a challenge to sand. I was trying to be very careful to not accidentally break the tail, but the tail was slowly getting shorter and shorter. Eventually, I realized it was much more efficient to move the sandpaper instead of the drop. Shockingly, the tail of the drop broke, but the head didn't, so I just kept on sanding and sanding and sanding until finally it popped. Sanding down the tail of a glass drop that explodes when it's broken sounds like a great idea. Using 220 grit sandpaper, the drop was definitely a challenge to sand. I was trying to be very careful to not accidentally break the tail, but molten glass versus grit. This glass drop explodes violently when the tail is broken, so I'm seeing what happens when I cover it in clay and then break the tail. The clay shapes easily around the drop, and I leave the tail exposed so that I can easily clip it. The clay unfurls in my hands, revealing the perfectly captured shards of glass from the Prince Rupert's drop. This glass. Previously, we tried making a Prince Rupert's drop in lemon juice, but unfortunately, it was unsuccessful. So, we figured let's try to make a Prince Rupert's drop. Exploding a Prince Rupert's drop under rice. Why? Because it's cool. And even cooler in slow motion. 7 layers of foam versus 1 Rupert's drop. First time it goes right out the side, so the second time I make sure to line it up better so it goes through all 7. This Prince Rupert's drop still be able to explode when it's dipped in candle wax like it's a candle? It has a nice layer of wax on it, and when I break the tail, it makes makes chunks of wax with glass embedded in it. Will Prince Rupert's drop still be able to explode when it's dipped in candle wax like it's a candle? It has a nice layer of wax on it. Chunks of wax with glass embedded in it. Will Prince Rupert's drop still be able to explode when it's dipped in candle wax like it's a candle? It has a nice layer of wax on it, and when I break the tail, it makes chunks of wax with glass embedded in it. This molten glass dripped into pine salt. Will it make a Prince Rupert's drop? It's mainly water-based, so it should work, but unfortunately the first one cracks. The second one was more successful and didn't break when cooling. The resulting drop is not too different in color than the liquid it was made in, withstands blows from a hammer, and explodes still. Molten glass drip. I wrapped 8 sparklers around this piece of glass to see if it could make a Prince Rupert's drop. I light them all on fire, and theoretically they should heat up the glass, melt it into this water, and make a Prince Rupert's drop. I let the sparklers burn down all the way to the end to reveal that they did in fact melt the glass, but it was not enough to drip it into the water and make a Prince Rupert's drop. It did make a cool curly cue though. I wrapped 8 sparklers around. I'm dripping molten glass in everybody's favorite flip. We all agree that bread tastes good, but what happens when you drip molten glass onto it? It smokes and sinks into it. I love the smell of burnt toast and Rupert's drop made in oobleck. Mixing water and cornstarch makes something called a non-Newtonian fluid, which has the same properties of a solid and a liquid at the same time. But is it a liquid enough to make a Prince Rupert's drop in it? It floats on top, making a kind of gel material where it's directly in contact, and a harder patch of non-Newtonian fluid. But the drop doesn't explode, so it's not a Rupert's drop. I'm dripping molten glass onto wood. I don't expect it to make a Prince Rupert's drop, but I kind of hope it lights on fire. Sadly, it just smokes and makes a crater in the wood. But it is a cool looking drop. Just to check, I'll hammer it. And first the tail breaks off. And then it breaks, but does not explode. Surprisingly, motor oil is a viable material to make a Prince Rupert's drop. It's durable and explodes. Here is slow motion of breaking one under motor oil. I'm the only one on the planet. Acetic acid, when diluted, I'm going to drip molten glass into my used motor oil to see if it will make a Prince Rupert's drop. The oil is 0W20 to 5,000 miles, and it bursts into flames when the drop falls into it. Maybe that will give it special properties. It appears to be a successful Prince Rupert's drop with long, straight tail and an interesting ball at the end. It's not a Prince Rupert's drop unless it explodes, which it does. The tail is broken off, but it is still extremely durable. Yesterday, I tried making a Prince Rupert's drop in honey, but it was unsuccessful. Today, I will be trying breaking a Prince Rupert's drop in honey. I hypothesize that the viscosity of the honey will hold the drop together after it's broken. And this is proven to be correct as it sinks to the bottom, still held together. Yesterday, let's see if I can make the sweetest Prince Rupert's. Can I make a Prince Rupert's drop in milk? It's 87% water, with the other parts being whey protein and fat. So, it should work like normal water, right? Unfortunately, the drop on the first attempt crumbled, so I tried a few more times to make one, and each time the drop crumbled. It might get me in hot water, but I'm making a Prince Rupert's drop in it. Prince Rupert's drops gain their properties when they cool rapidly in cold water, so will it work in hot water? The first few broke shortly after cooling, but finally I got one to work. But does it still retain its properties of being explosive? No better way to test that than start cutting far at the end of the tail, working my way up to the head until it explodes. I've proven it. You can make a Prince Rupert's drop in hot water. When I hammer this glass rod, it breaks like you'd expect. But if I melt a drop of glass from a similar rod into water, will colored water make colored Prince Rupert's drops? Will dripping molten glass? I'm going to drip molten glass. Will it Prince Rupert's drop? Egg edition. After dropping it into the egg, it appeared to start cooking the white around it, sizzling and popping like it was frying in a pan. Taking it out of the glass, it's almost like the Rupert's drop has its own shell of white around it, and thus hatches a curly Q tail having drop. Will it Prince Rupert's drop? Saltwater edition. Salt makes water freeze at a lower temperature, but will it have any effect on the formation of a Prince Rupert's drop? Let's test how salty this water is. Can you get some water? Thank you. underestimated that. And it retained its explosive properties. Will it, Prince Rupert's Drop, saltwater it? I'm going to be able to make giant Prince Rupert's Drop, but right now I'm still adding all the wood in the furnace. The first trip would not actually catch. I light it right, but all I got were fire Rupert's Drop with my normal torch. But it's a cute one. I can't wait for a giant one. I want to make Prince Rupert's drops as big as my fist. The bigger a Prince Rupert's drop is, the stronger it is, and the more energy is stored within it and is released when it breaks. I can only make small Prince Rupert's drops right now because I only have a small torch. It can only heat up a small amount of glass. I will need to either build myself a larger furnace or get access to a professional glass studio. I want to make Prince Rupert drops are fascinating. They're made by dripping whole glass in cold water. The head of the drop is super strong and can't even be smashed with a hammer. But if you snap the tail of the drop, it explodes into a million pieces. This is because the outside of the glass is under extremely high compressive stress, and the inside is under high tensile stress, due to the unique properties making it both strong and weak at the same time. The Prince Rupert's drop is an intriguing. You guys didn't get my lunch. Well, I know what happened to Mommy's pizzas. Oh, fuck! Holy shit! What's this? It's an art project. Okay, I like it. Picasso. Yeah, that way. Sheriff's deputies arrest a man who they say has more than he can handle. Y'all, everyone gangster till Captain America shows up. Oh, man. You think it's wrong that a plumbing company will charge you extra if they find Drano in your clog sink when they show up? Now, never do what I'm doing here. You're not supposed to use a plunger after you put Drano in. It's very dangerous. You could lose your vision. One asked me, why do they even sell drain cleaners? Well, the point is that they do sometimes work, otherwise nobody would buy them. A more desirable way to clean it is going to be to remove the trap and snake it. But yes, she is gushing out now. You got to be careful. You don't want to get splashed in the eye on this. Wear gloves. But JD's and Lauren, welcome to How Many Slim Jims Can Hold? 5 Slim Jims. Fuck. Not fucking 35. 37. Oh my god. Oh shit. 40 Slim Jims. Holy shit. 40 Slim Jims. JD's and Lauren, welcome to How Many Slim Jims Can Hold Me? 1 Slim Jim. 2 Slim Jims. 3 Slim Jims. 5 Slim Jims. 10 Slim Jims.
If you're going to raise domestic silk moths, there's something you got to know. And that's that even if your moth makes enough fluid to get through the cocoon, most of the time, they still don't push through the cocoon. The reason for this is that the cocoons are 2 to 3 times thicker than when they were wild moths. This has been done for over thousands of years, and there is no undoing it. Same thing with their flying. They'll never going to have all of his poop all over him. And don't be rude to him. He's still adorable, even covered in poop. It's not his fault, so we really should.
Knowledge, that's not too difficult to do. Here, we can. So, were you successful? Let's do this together. Now that we learned about comparison operators and logical operators, here we could say that we want to print this if the name is Max. So here, instead of hard coding true, we could say we want to make sure that we add this warning clause here to the input and to
I thought I did add that. What the fuck? Yeah, this is crazy. I thought I. What the fuck is this called? No, the fuck. Bruh.
And judge him.
Sharpness test. 3, 2, 1. What? No damage. Cheap, soft, Chinese cleaver. You again. You gotta be kidding. 1700. How to turn this 1700 reading knife into a sharp one? Soft cheat? I'll try the Pro Edge Circle. Daily prep. Daily sharp. Daily fine. Sharpness test. 3, 2, 1. Okay. 130. Not bad. Fully up. Sharpness. Sharpness test. 3, 2, 1. What? No damage. Cheap, soft, Chinese cleaver. You again.
the remaining characters span if we have less than 10 remaining characters. And with our newly gained knowledge, that's not too difficult to do. Here, we can just write if inside of this function here. I'm inside of this function, and here I'm writing if. Then you learn that we need parentheses and then curly braces. Now, the code that should eventually be executed if the condition is met goes between the curly braces, but the condition goes between those brackets here. And the condition here is that remaining characters is smaller than 10, or smaller and equal than 10. So here we can refer to remaining characters, which is the number inferred with this calculation, and then use the smaller or equal operator and compare it to 10. Now we also see how we can derive such a Boolean without a hard-coded value. Now the code that should eventually be executed if... So, were you successful? Let's do this together. We want to make sure that we add this warning clause here to the input and to the remaining characters span if we have less than 10 remaining characters. And with our newly gained knowledge, that's not too difficult to do. Here, we can just write if inside of this function here. I'm inside of this function, and here I'm writing if. Then you learn that we need parentheses and then curly braces. Now, the code that should eventually be executed if the condition is met goes between the curly braces, but the condition goes between those brackets here. And the condition here is that remaining characters is smaller than 10, or smaller and equal than 10. So here we can refer to remaining characters, which is the number inferred with this calculation, and then use the smaller or equal operator and compare it to 10. Now we also see how we can derive such a Boolean without a hard-coded value, because of course remaining characters will be inferred dynamically whenever this function executes, which happens on every keystroke. And remaining characters will be different on every keystroke. And only if it's smaller or equal to 10, the code inside of this if block, as it's also called, will be executed. And in here I want to add this warning clause, and therefore I can reach out to remaining chars element, which is this span, and there use this class list object we learned about to add this warning clause. And we don't just want to do that on that span here, but also on the input. So here on this product name input element, here, I also want to reach out to class list and add warning. And with that, we can save this. And now in index.html, we just need to make sure that we again import demo.js so that we link to that script. And then if you save this as well and you go back, you will notice that as soon as we go beneath 10 characters, this turns orange here, this number, and the background of the input field, because we have that warning clause added here. And also, of course, on that span. Now, at the moment, it never goes away if we go above 10 again, because we have no logic for that. But that's something we'll dive in next. Here, however, we already see control structures in action, and we also see why we often need them. Now, we got our first if statement in action that does something useful. It adds these classes if we have less than 10 remaining characters. But at the moment with that, of course, whenever we go beneath 10 characters, that works as expected. But if we go above 10 remaining characters again, then the warning clause is not removed. It's still applied, and therefore we still have this orange color. Now, that's working as expected, because with this if statement, we only add the warning clause. We have no code that would remove it. And just because this code doesn't run with every execution of this function does not mean that past executions of this code would be undone if it does not run again in the future. So if this code ran once because we went beneath 10 characters once, that's enough. The class has been added and it will not be undone unless we reload this entire site and therefore restart our JavaScript code, so to say, as we restart everything on this page. So if we want to remove this warning clause as soon as we are above 10 characters again, we need to alter this if statement a little bit, and we need to add a so-called else statement, a else branch to it. Because that's another key feature of if statements, not just in JavaScript, but again in basically every programming language. You cannot just define a condition and then code that should be executed if the condition is met, but you can also define code that should be executed if that condition is not met. And you do this by adding the else keyword here right after the closing curly brace of that if statement code block. And then you again add opening and closing curly braces. And now we extended this if statement and we added such an else branch. And now you can put code into that else branch code block here between these curly braces to execute that code only if that condition here should not be met. Now, you don't need an else branch for every if statement you write. It simply depends on what you want to achieve. But very often, such an else branch can be useful to execute some alternative code. And here, the alternative code would be that we want to remove the warning clause. So by calling the remove method instead of the add method. And the great thing about remove, by the way, is that if it should run when no warning clause has been added yet, it will just not do anything. So it won't cause an error or anything like that if it finds no warning clause. But if it does find one, once this code executes, this warning clause will be removed. And now with such an else branch added here, if you save that code again and you go back, you can see that if I type something into this input field here, now the warning clause has been added. But if I remove characters here, then as soon as I'm greater than 10, you see
What? Remove.
the now see that it's moved.
Oh, many char element. class.remove warnings. Product class plus remove warning. Bam.
And now with such an else branch added here, if you save that code again and you go back, you can see that if I type something into this input field here, now the warning class has been added. But if I remove characters here, then as soon as I'm greater than 10, you see the styles change because that warning class was removed. And you can see it flash here on the right as the warning class is added to the DOM, so to the parsed and displayed HTML content, and as it is removed thereafter. And that's now working the way it should. But an else branch is not all you can add. Sometimes you even have different conditions which you want to check. Maybe we want to add a brand new class if we have no remaining characters. Maybe we want to add a red background then. And we want to add the warning class if we have less than 10, and no class if we have more than 10 remaining characters. To achieve this, we could change this code and say that if remaining characters is equal to 0, using the triple equal sign comparison operator, since this is a best practice, so a pattern you should typically follow. And with that, we would now only execute this code if remaining characters is equal to 0. Now let's say in this case we want to add an error class here. Not a warning class, but an error class. Now this is a class we have yet to add in our CSS code. So let's quickly go there to style CSS. And maybe duplicate these two rules. So copy it. And paste them, but replace warning with error here, like this. And now let's pick more reddish colors. So here I'll go more into the red color area and have a light red color as an input background, and here have a red color as a span text color. And that's now this error class, which will be added if we have 0 remaining characters. And with that, we of course want to remove that error class if we have if we have more than 0. Remaining characters, but, and that's not a tricky thing, we also want to have a condition in between 0 and this else block here. And for that, we can also add an else if statement to add multiple conditions that are evaluated step by step. For this, we add else if like this after the closing curly brace of the if block. And then we add opening and closing curly braces to define the code that should be executed if some other condition is met. And to add this other condition, we also add parentheses here to put our condition between those parentheses. And then this else keyword here goes after the closing curly brace of the else if branch. Here we can now define another condition, for example, that remaining characters is smaller or equal than 10. So what we had before. And in that case, I'll copy this code. In that case, we can add this warning clause here like that. And in the else branch, we therefore now don't just want to remove the error clause, but we also want to remove the warning clause. Like this. By the way, you can also rewrite this and simply pass multiple parameter values to remove and pass all the clauses you want. To remove as individual class names like this. That will also work. Now with that, we added our else if condition. And how will this overall conditional block now be evaluated by JavaScript? Well, it always starts at the top. That's always how your JavaScript code executes, top to bottom. And it first of all has a look at this condition. If this condition is met, we go in.
Goes.
Here, and the rest of this if block is ignored. So the else if and the else statement will be ignored if this first condition is met. If it's not met, so if we have more than 0 remaining characters, it will move on to this else if condition and evaluate this condition. If this condition is met now, it goes in here and executes this code and ignores the else block. If this condition here is also not met, then this code is of course not executed, and instead JavaScript moves on to the else block and executes that code instead. And therefore with that, if we save all of this, if I start typing here, initially nothing happens, but if I go below 10 characters, I have my old warning clause added. If I go above 10 characters, it's still removed. And if I go to 0 characters, I have that error clause added in addition, hence I have that red background and that red color here. But if I go above 10 again, both is removed. Now the error clause is actually not removed as soon as I am above 0, because we only execute this remove command in the else branch, so only if we also are greater than 10. If you would want to remove the error clause as soon as possible, you would have to add that remove code here to this else if branch. So we would have to copy that and remove error and only error as soon as we are inside of this block. And only remove warning down here if we are in the else block. With those adjustments made, now you would see that if we enter something here, if we enter some text, now the error clause is removed as soon as we have at least 1 remaining character, and warning is removed if we are above 10. And that's how we can run code conditionally with if statements, and how we can use extra features like else if and else if we need them. Now we understand how if statements work and how we can use comparison operators to check different conditions. There is a little extension, some extra knowledge you should have about Boolean values and if statements, though, which I want to dive in now. For this, I switched back to including the conditional code.js file here in the index.html file. And in this conditional code.js file, I now want to show you a different way of using Boolean values and of writing if statements, which is also very common in JavaScript. Up to this point, we always derived Boolean values by writing comparison code like this. And that is super common. But sometimes you also have so-called flag variables, which have a true or false value stored inside of them. And an example could be that you're building a website where users can log in, and hence in your JavaScript code that adds a certain functionality to the page, you might be storing the current login status of the user because your code execution depends on whether a user is logged in or not. For that, you could have a constant here, or a variable, doesn't matter, which you could name isLogkedIn, which is a kind of name we haven't used up to this point, but which is a naming convention you'll use very often when you store Boolean values. Because you want to describe what's stored in a variable, and here I want to store true, let's say. So not the result of some comparison, not a number, not a string, but true as a value itself. And then isLogkedIn is a quite fitting name if this variable stores the answer to the question whether the current website visitor is logged in or not. So here I'm storing true, could be false, doesn't matter, it's just an example, in that variable named isLogkedIn. And now we might have some code that should only be executed if this is true. And here, of course, it's hard-coded, but again, we could be fetching this from some other part of this website, and hence this could be dynamic. Let's imagine it is. Now we can write an if statement, and we can, of course, then, for example, console log user is logged in. We could do that. Now in this condition, we now might want to check if isLogkedIn is true or false. And for that, we can, of course, compare isLogkedIn to true and say this code should execute if isLogkedIn, this variable, has stored true. Fetching this from some other part of this website. And hence this could be dynamic. Let's imagine it is. Now we can write an if statement, and we can, of course, then, for example, console log user is logged in. We could do that. Now in this condition, we now might want to check if isLogkedIn is true or false. And for that, we can, of course, compare isLogkedIn to true and say this code should execute if isLogkedIn, this variable, has stored true as a value. That would work, and there's nothing wrong with it. But keep in mind, this condition here in an if statement, or also in an else if block, of course, wants a Boolean value in the end. And we use comparisons like this or like this because those comparisons do yield Boolean values. Now, isLogkedIn actually already has a Boolean value stored. So this is kind of a redundant comparison. We can also just write if isLogkedIn like this. And if that's true, which it in this case is, this code will execute. If this would be false, then this code would not execute. So if I save that, I get user is logged in here. Now let's say we would want to have the opposite check, and we want to say user is not logged in here, then we might want to check whether is logged in is false. And again, we could therefore write this, and that would be correct, but we can also shorten this and just write if not is logged in with that negation operator, this exclamation mark. With that, we're saying if this is not true, then this code should execute. Here, of course, it is true, and therefore, if I save that, we have no output from that if statement here, because we don't make it into this if statement with this condition and this value. But knowing that you can store Booleans in variables, as I'm doing it here, and how you should then name these variables, that you should name them as if they answer a question, and that this is also a common thing to do, and how you can then use these Boolean values in if checks, that is important. Because again, that's also a certain way of working with Booleans and if statements, which you will see a lot in web development. Now, building up on what we learned in the last lecture about storing Booleans and having checks like this, there is another important concept in JavaScript, which you don't find in most programming languages, but which is a key part of JavaScript and which you therefore also have to know. Let's say we have a constant, or a variable, doesn't matter, entered user name. And that could be Maximilian, it does not matter. Now let's assume this is again a value which we actually fetch from some input field, just like we do it in Demo.js. There we also get some entered value. Let's assume the same is the case here for entered username. Now we might have some code that should only execute if this is a non-empty string. And then we could say, input is valid. So we could check if this is a non-empty string, if it has more than 0 characters. Now for that, we can write enter the username and get the length of that string with the length property and check if that's greater than 0. And if it is, which it in this case is, then I can save this and I get input is valid. But if that's all we care about, there is an even shorter way of checking this. Non-empty string if it's valid. So we could check if this is a non-empty string, if it has more than 0 characters. Now for that, we can write enter the username and get the length of that string with the length property and check if that's greater than 0. And if it is, which it in this case is, then I can save this and I get input is valid. But if that's all we care about, there is an even shorter way of checking this. We can also write if enter the username, like that. And if I save that, I also get input is valid. And if I go back and I turn this into an empty string, so no input was provided, then I actually don't get this output. So this also works as we would want it to work, but why? Because JavaScript has this concept of truthy and falsy values. Now we have true and false for booleans. But in a place where JavaScript wants a boolean, like in this if condition here, if you provide a non-boolean value, JavaScript will basically try to convert that provided value to a boolean, and it has certain rules for that conversion. Now I got dedicated deep dive courses where I dive way deeper into all the niche details of how JavaScript does this conversion, and I dive into all the tricky cases where this conversion might be strange, but it's generally straightforward. An empty string, or the number 0, will be treated as false. A string with 0 inside of it would not be treated as false, since this is not an empty string. So empty string or 0 are basically treated like false. A string with anything in there, even if it's the text false, would be treated as true because it's not empty. So it's really only the question whether it's empty or not that matters. Even a blank character would count as not empty and therefore as true. And hence, if you use a string or a number here, then this will be treated as true if it's not empty or not 0, and it will be treated as false if it is an empty string or a 0 number. And that's why this check also works. This might sound like a niche case, but it actually isn't. Very often you will perform checks like this simply because it's shorter than checking for a length greater 0, and it has exactly the same result. So whilst you could do that, this is simply shorter, and it works because of this truthy, falsy behavior that's built into JavaScript. Now, if that's still a bit much and a bit confusing at this point, again, don't worry, we'll have many examples throughout this course. But as we are talking about if statements and booleans right now, that's definitely also a concept that needed to be introduced at this point. Now, with if statements, we explored one super important control structure, which you will use all the time in programming. It's super important, and we will see it being used a lot throughout this course. But you learned that besides if statements, we also have loops as another super important kind of control structure, or a set of control structures. Because loops allow you to execute certain code multiple times, depending on different circumstances, we will learn. And there's also not just one kind of looping code, but there are different kinds of loops you can write, depending on what you want to achieve. Now, the concept of having loops is a concept you will find in all programming languages. It's just the exact kinds of loops that are supported that will differ throughout those different languages. Now, before we dive into the different kind of loops JavaScript supports, let me show you a little demo page which I prepared, which we are going to build throughout this course section. This demo page consists of 4 examples, and these examples use different kinds of loops JavaScript supports. So these examples use JavaScript code that utilizes loops to achieve the result we see here on this page. For example, in this first example here, we can calculate a number where we sum up all the numbers leading up to a number of our choice, from 0 up to this number here, and we then show this result here. And under the hood, we are repeating some code here when we add up that number, and that will be done with a loop. We also have another example where this button will highlight all the links you see in the text below. And again, this performs basically the same operation 3 times on these 3 different elements. So again, we have repeated code, which loops are all about. I have another example where I display some dummy user data once I click this button. And here I'm basically displaying the content of a JavaScript object, the different properties of that object and their values. And if you look closely at this example, it's again basically a repeated operation. I'm adding list items to a list, and every list item contains a property name and its value. And this operation is repeated 3 times. Again, another example for a loop, which you will see in action as we will rebuild these exact examples later in this section. Last but not least, here we can test our luck and see how often we need to roll the dice until we roll a 4 in this example, or a 3 here. So that's another little example here with some randomness included, where we actually use loops to implement this functionality. And these are things we can do with loops in JavaScript. These are all examples that rely on some code repetition, and therefore we will rebuild these examples later on in this section to see how loops work. But before we get there, let's first explore which kind of loops JavaScript supports and which problems they solve before we then dive into some actual code. In JavaScript, you have 4 loops, you have 4 off loops, you have 4 in loops, and you have while loops. And of course, I'll explain all. You have 4 off loops, you have 4 loops, you have 4 off loops, you have 4 in loops, and you have while loops. And of course, I'll explain all of these loops with concrete examples. Over the next minutes. With 4 loops, you can basically define a certain number of times some code should be executed. With 4 off loops, on the other hand, you can loop through all the elements in an array and then do something with every array element. So 4 off is used for working with arrays, and 4 can also be used for working with arrays, but it can also be used without arrays. Again, I will show you some concrete examples soon. For-in loops are a bit like for-of loops. The difference is just that with for-in loops, you can loop through all the properties of an object. So for-in loops are used for objects. And while loops are a bit different, there you don't define a certain number of times in advance, and you don't loop through an object or an array. Instead, with while loops, you define a condition, so you work with Boolean values, and a loop, the code is in the loop will be executed as long as a certain condition is met. Now, all these loops have their purposes, and you might need them for different purposes, therefore, but especially for-of and for-in are used quite frequently. Nonetheless, you need to know all four loops, and hence I will show you all four loops here. Now, one short word about this demo page before we continue, by the way. This demo page has 4 examples, and for each example, I'm using a different kind of loop. I'm using all the loops you saw on the slide before, basically. And therefore, let's now explore the theory behind these loops. Let's write some code, and then let's rebuild these examples. Now, to explore those loops, I'll add a new file, loops.js, in our project here, and replace it. Demo.js with loops.js in index.html. So that again, we can execute some code here and then see the result in the console or on the screen, depending on what we need. Now I'll start with the console and the regular for loop. So not for-of or for-in, but just the for loop. You write this loop like that. You start with the for keyword, then parentheses, and we'll put some code that determines how long the loop will run into those parentheses. And then curly braces, and between those curly braces, just as we had it with the if statement and functions, we put the code that in this case should be executed as long as the loop is running. Now here between those brackets, we have to write some code that defines how long the loop is running. And with a for loop, the execution of that loop code depends on some variable, some helper variable, you could say, that is defined for this loop. For that, we write let, and that's important, it must be let, not const here. Let I, typically, I stands for iteration. The name is up to you, and it can also be longer than one character, but I is a very common variable name for this for loop variable.
Oh,
And then
I need to write that down. That's always bugged me.
after let I, you add a semicolon. However, you can and typically do assign an initial value here, and that very often is 0, but it can be anything. Then after this semicolon, still between those parentheses, you write your looping condition. So some condition that defines how long that loop should keep on running. And it could be that you want to keep looping as long as I is smaller than 10. So here in this comparison, you typically use this helper variable, which you define as a first step. Now we add another semicolon, and now we define how I should change in every loop iteration. And very often here, we will increment it by 1. So we will add 1 to it. And in JavaScript, there is a shortcut for this, which you can also use outside of the loops, and that's I++. Plus plus is a special operator, which is equal to this. So it's equal to reassigning I to a new value where I is the old value plus 1. That will add 1 to I and store this back into I, and this is simply a shortcut notation for it. You also have a similar shorthand for decrementing I, with I minus minus. That would be the same as writing I equals I minus 1. But again, here we need I plus 1, and therefore, again, I will use this plus plus shortcut. With that, I will be incremented by 1 after every loop iteration, and that's important, after the iteration, so after the execution of this loop code. And this loop code will be re-executed as long as I is smaller than 10. So with this code, we would write a for loop that executes 10 times. Because we start at 0, add 1 to it after every execution, and keep on executing as long as it's smaller than 10. Not smaller or equal, but just smaller. However, you can, of course, tweak this however you want. You could also make this smaller or equal, or maybe change I such that it's actually I plus 2 in every iteration. In that case, of course, you would loop less times because you add more to I after every iteration. But here I'll stick to I11, and I will console log I here, so that we see how I, this helper variable, changes during all those iterations. As a side note, I is a variable which you can only use inside of this looping code. Not outside of it. If I would try to console log I here, outside of this loop, you will see that it's not getting logged. But speaking of that, let's save everything and go back. And you see I get an uncaught reference error here. That's coming from me trying to log I down there, so I'll get rid of that. But if I save this again, we see that other than that, we have I from 0 to 9 being logged. So the loop executed 10 times, and I changed accordingly. We don't see I equal to 10 here, because for I equal to 10, we don't make it into this loop with this condition. But again, as mentioned, you could change this condition. So when could this kind of loop be helpful? It is helpful whenever you know that you have some code that should be executed a certain amount of times. For example, if you're building an online game in the browser where the user can roll 2 dices, and therefore you know that you want to generate a random number between 1 and 6 2 times. Then you could write such a loop to execute this random number generation code 2 times. For the moment, I'll keep it at this example here, though, and I'll move on to the next kind of loop which we have, so that we see all those different loops here in theory and in action, before we then see what we can do with them when it comes to more realistic examples. Now, besides this for loop, we also have a for of loop. And even though it sounds familiar, it works totally differently. Let's say we have an array of users, and this is simply an array with a couple of names in there, like this. And now we want to do something with every user. In a real website, we might want to send an email to that user, or just show that user on some dashboard screen. Here, I'll just log these usernames. Now, of course, I can console log users, and if I do that, it will work, but it will simply log the overall array. That's not what I want here. Instead, I just want to log the individual names, because, again, we might be doing more useful things here and send emails to the individual users instead. And that's where for of loop can help us. We again start with the for keyword, and then we again have brackets and curly braces. But now between those parentheses here, we don't write code as we did it up here, but instead we create a helper constant. User could be the name we want here. The name is up to you. It should describe your individual array elements, though. And since here I have users, an individual element could be named user. And then we add the of keyword thereafter, and then we point at the array through which we want to loop. in my case, the users array. And with that, we loop through all the elements in users, and we get access to the individual elements inside of that looping code under this helper constant. And here it's a constant and not a variable, because it's basically a brand new variable that will be created for every iteration, whereas in the first kind of for loop, it was the existing variable that was changed. It's a slight difference. That's why we can use the const keyword here. Of course, you could also use let alternatively, but I'll use const since that is what you'll see more often out there in the wild. And then here I can console log user, so not users, but user, to log the individual elements for every iteration. Now with that, if I save that, you see here at the bottom, Max, Anna, and Joel printed out as 3 individual elements. Because this for off loop now executed the code in here 3 times, once for every element, and it gave us access to every element.
Using the regular for loop with arrays. Years ago, we didn't have the for of loop in JavaScript. To still loop through all the elements of an array, this code could be used. This code still works today, and you can absolutely use it instead of using a for loop. But of course, it's longer and a bit more clunky, so there is no strong reason to use that unless you prefer it. Let I equals 0. Let I equals 0. Some array. The length. That really doesn't make any sense to me.
Now we also have a for in loop, and the difference is that for in is meant to be used on objects. Let's say we have a logged in user object here, and I'm just coming up with some example data here. We're still, of course, just exploring some dummy use cases here. And that logged in user has a name, which is Max, a age, which is 32, and a is admin property. property, which is true. And here we see a Boolean value created and assigned just like this, because that is also a common use case for Booleans, that we store them just like this in variables or properties that act as flags, so that tell us whether a user is an admin or not, for example. And now that I got these 3 properties, we could output these key value pairs here with help of a for in loop, if we had some code that needs to access all these properties and transform the data into some other format or do anything else with them. For this, again, we start with the for keyword, and then again we create a helper constant, but this constant will then actually hold the different property names, or keys as we can also call them. And hence you very often name this key, but the name is up to you. We could also name it with the format or do anything else with them. For this, again, we start with the for keyword, and then again, we create a helper constant, but this constant will then actually hold the different property names, or keys, as we can also call them. And hence, you very often name this key, but the name is up to you. We could also name it property name. The important thing to note is just that it will be the name, not the value and not both together, just the name. Then we use the in keyword here, and then we point at the object through which we want to loop. So in this case, for property name in logged in user. Now in here, we can now console log property name to see what's stored in there. And if we save that code, you will see name, age, and is admin being printed out here at the bottom, because these are the three property names we have in here. Now if you want to get access to the values as well, that's possible with help of a special kind of syntax which we haven't seen yet. We can console log the logged in user and now dynamically access the different properties stored in the user. Up to this point, when we wanted to access a property, we always did that with the dot notation, to access logged in user.name, for example. But that won't work here, since the property I want to access is actually different in every execution. And to access such property names dynamically, we can use a syntax which we already know from arrays. We can add square brackets here after logged in user, even though that's not an array but an object, but there you can use square brackets as well. And between those square brackets, you can put the property name as a string. So for example, name. I could access this like that as well, and that would be equivalent to logged in user.name. But since we have this syntax, we can now also not hard code the property name as a string here, but instead refer to property name, or helper constant here. And property name indeed holds the different property names as strings, so therefore this line of code will dynamically access the values for those different property names, which are different for every execution. That's how we can access property names dynamically. This does not work with the dot notation, because if you had logged in user.property name, it would look for a property named property name, not having the name stored as a value inside of property name. So that won't work, but with the square bracket notation, we can dynamically access values by that dynamic property name. And hence, if we save that, we get name, max, age, 32, and is admin true. So that's then working as it should. Now, the last kind of loop I mentioned on the slide was a while loop. And with the for loops, we basically always had like a fixed number of times the loop executed, either because we defined it here or because we had a fixed amount of array elements or properties in an object. With while, we instead just have a condition on which we depend. And as long as that condition is true, we continue. Now let me show you an example. We write a while loop by using the while keyword, then parentheses, between which we can put our condition, and then curly braces. As long as the condition we put in here is met, we'll continue executing this code. So if I would write while true here, we would create an infinite loop. And therefore, you should not save this, because this will crash your website since it will never end. Instead, we could be doing something like this. We could add a variable, is finished, and that could store a Boolean value. So initially, it could be false. Here in the while loop, we then check for the opposite. We want to keep on running as long as we are not finished, hence we can execute not is finished here. And in here, we could now show a confirmation dialog to the user with help of the confirm function. It's basically an alternative to alert, but confirm allows us to answer with yes or no. And therefore, it will return a Boolean value. We can then enter the message that should be shown to the user, like, do you want to quit? And this will open up an alert box, which already has a yes or no button. And hence, since this will return a Boolean, we can store this in is finished and overwrite this is finished variable value with the response of the user here. And if the user chooses yes, he or she wants to quit, is finished will be true, and then not true will be false, and the while loop will quit. So thereafter, we could console log done. But that will only execute if that while loop stopped, because as long as this keeps on executing, this code will not be executed. So if you save that now and you reload this page, you get this prompt, do you want to quit? And if I click on cancel, which means no basically, I get this prompt again, until I find click OK. So if you save that now, this code will not be executed. So if you save that now and you reload this page, you get this prompt, do you want to quit? And if I click on cancel, which means no basically, I get this prompt again, until I finally click OK, and at that point we get done down here and we don't get this confirmation box anymore. And again, it's still just a dummy example, but it shows us really well how a while loop works. And these are the key loops we have in JavaScript. Now that we explored them in theory, let's have a look at more concrete, realistic examples. Now, to practice more JavaScript and explore loops in more realistic examples, I attached another zip file, this loops in action zip file, which you can extract to get this folder with this HTML and this CSS file, which you see here. And these are the two files we will work on, and a JavaScript file, which we will create over the next minutes. So we can ignore the other content of this project folder for now. That's what we will continue working on. So simply add this extracted loops in action folder to your overall project folder in which we've been working, and then as before, simply open the index.html file with that live server extension so that you see it on the screen. And that is the example I showed you a little bit earlier in this course already, but without any functionality. Clicking these buttons doesn't do anything because that is exactly what we will work on. And therefore, let's now work on this together. And here in this first example, we want to build a simple calculator where we can enter a number here. And when we click that button, we add up all the numbers leading up to this number and output the overall sum here in this box. For this, in this index.html file,